Yeah, it is. Okay, so let's have a look here. So on this first problem, this is something that we did a long, long time ago. Remember I showed you guys a great trick when you're solving an equation that involves a bunch of fractions, right? It's a real pain to do. I mean, technically we would just add up like terms and then divide by the coefficient of x, right, to isolate x. But the problem here is that there are a bunch of fractions. And so adding up these fractions, every time we do that stuff, right, we try to isolate x, we're doing arithmetic that requires us to deal with fractions, right? Fractions are harder to do algebra with than integers. I mean, we all know that. So the trick is we can clear the fractions. Now, what's our strategy for clearing the fractions? Tyler, you remember this. What do we do to clear the fractions? I know you know this. Okay, we find the least common denominator, right? And what is that, by the way?
30. It's 30.
Not 30.
Wait, is it just 2 and 4, or do you include 5?
No, it's everything. Oh. So what's the smallest number they all divide into?
20.
20. Good.
Wait.
Is that you? Okay, so then what we do, remember, is we're going to, let me do this, see if I can just grab, there we go. Oh, took the C. That's unfortunate.
Can you just say?
Come on, just stay right there. Oh, well, it's taking the C. You get the idea. Now what it do? Oh,
Undo it.
it's all messed up. Anyway, we're clearing the fractions. Yeah, I don't even need to rewrite it. We know what we're doing. We're clearing the fractions, right? So then we're going to multiply both sides through by the least common denominator. We'll distribute it through both sides. So if I multiply 20 through on the left, remember how we did that? There's a definite best way to do this. Normally when we're multiplying fractions, we would just probably multiply straight across and then simplify. But we know we purposely built this number, the least common denominator, to be a multiple of all of the factors, right?
Distribute it to each term?
We do, but when we distribute, instead of multiplying straight across and getting like 60x over 4, we're always going to reduce first, because we know that 2, 4, and 5 are guaranteed to be factors of the least common denominator, because that's what it means to be a least common denominator, right? Yeah. Okay, so then remember how we did this before. We'll say 20 divided by 2 is what?
10.
And then we just multiply that by the top, right?
So
Remember this stuff?
Yeah.
So we end up with 10x, right? 20 over 4 is 1. So we'll multiply the 5 by the 3x, and we're subtracting, right? Everybody see? Over here, 20 over 5 is 4, right? And so we end up with 28. And then that's easy. I'm not even going to go any further. From there, we just collect like terms and isolate x, right? But the point is, the clearing the fractions part is the thing I wanted to remind you about, right? So that's the same way to think about it. If you just, and this works great in math and science. Whenever you're trying to think of a complicated concept, see if you can compare it to something simple. And a lot of times, that makes life a lot easier. It's a lot of times in physics, we do something called the principle of exaggeration, which is just that. If you exaggerate something and make it extreme and simple, then sometimes the relationship is easier to see. So what about this? Same kind of thing, right? We're just solving an equation with variables in it. The only difference being this time the variables aren't in the top. Yes, ma'am?
So do we just leave the 10x?
No, so if we were going to finish that up, what we would do is we'd go ahead and,
Negative 5x.
yeah, we'd combine like terms and get negative 5x equals 28, divide both sides by negative 5, and so we get x equals positive over negative is negative 28/5, right? Okay, so now to move forward with this though, to look at a different situation where we've got a different kind of fractional equation, we're going to apply the same concept to this. So what is the least common denominator of this? You had an assignment at the beginning of 9-1 where you practiced this.
21.
No, it's not 21, because it's got to be Remember what the least common denominator is. Now just think, now listen to this carefully and think hard about this for a second. The least common denominator is going to be the smallest product of factors, right? That's going to include the factors from each fraction, right? So what are the factors up here in the denominator?
3, 1.
P, now, P is not 1 and 3 is not 1. Those are terms. The factor is the whole thing, right? The whole denominator in this case is a single factor, right? If it were something like a quadratic expression, maybe we could break it apart into a product of smaller factors. But this one is already factored all the way, isn't it? Everybody agree?
Yeah.
So we get the factor P minus 3 and P minus 7. So our list needs to include both of those, right? Because they both have to be included in the least common denominator, right? Each of these has to divide into the least common denominator, which means it needs to be part of that product, okay? Let me demonstrate that. So the least common denominator is the product of P minus 3 and P minus 7.
And
Let's
then
show
you
that
do
that
the
works.
opposite.
Say it again.
You do the opposite, so then you times the first fraction by P minus 7.
Well, we're gonna actually multiply through by the entire thing, and there's gonna be some cancellation. But I just want to demonstrate real quick that P minus 3 does divide evenly into the least common denominator, because that has to be true, right? That's what the least common denominator means, the smallest product into which both of all the factors divide evenly, right, the denominators. So then what if we do that? What if we take the LCD divided by, let's just say, P minus 3. Well, look what happens. They cancel, and I end up getting P minus 7, no remainder, right? So it divides in evenly, right? And, you know, it's just, it will always be that way, right? Okay, so now we've got the least common denominator. The next step is going to be, I don't really need that up there. The next step is going to be, we're going to do what we did before. We're going to multiply, we're going to clear the fractions by multiplying both sides through by the least common denominator. But before we do that, this is really important. We have to make sure we make a list of excluded values. Because when we solve this, if our solution ends up being one of the excluded values, then it's not valid. It's extraneous and it doesn't count, and you can't list it, right? So what are the values of P in this case that we have to omit?
3.
Good, so P cannot equal 3, and P can, what?
7.
Not equal 7, and why is that again? Okay, there's zeros at the bottom. Those are values of P that would make a 0 on the bottom of a fraction, which is an unbreakable rule in math, right? You can't do that. Okay, so if we got 3 or 7, they wouldn't work because they're not part of the domain. They don't count.
So it would be the opposite.
Well, yeah, because what we're doing when we're finding the zeros, we're just setting these equal to 0 and solving. Or in other words, we're asking ourselves, what value of P makes that 0? Right, so that's how you can just do the algebra in your head. It's the same thing. If I set it equal to 0 and solve, I get P equals 3, right? So we can't have that one, okay? All right, so now we'll do the same thing we did before. We're going to multiply both sides by our least common denominator. That's supposed to be the P. So we end up with 6 over P minus 3 equals 12 over P minus 7. We'll multiply both sides through by this. Right? Okay, when we do that, what happens? We get some cancellation, right? Over here, the P minus 3 cancels. Over here, the P minus 7 cancels. And so we end up then with, on this side, if I expand that out, if I distribute the 6 all the way through, don't I just get 6P minus 42?
Yeah.
On this side, if I distribute the 12, I get 12P minus 36, and that's pretty easy to solve now, right? So what do we do to solve that?
Subtract 60.
Okay, good. I'll push the 6 P's, I'll push the P's over to the right so I get a positive number of them. Good. That's good. So while we're at it, let's be efficient about this. If we're pushing the variables this way, we're trying to isolate the variable. So where do the numbers go? That way. So we'll add 36. So the numbers are gone from the right, the variables are gone from the left. Negative 42 plus 36 is negative 6. equals 6p. So what's p?
-1.
Negative 1, good. Okay, is negative 1 part of our domain? Is it excluded?
No.
No, so we're fine. That works. Okay, that works. All right, let's try another one, a little harder one. Let's try something like this. Okay, so what about this? We're going to solve the rational equation. So what about this one? This time, this is actually pretty simple, right? What are the factors in the denominator of each of those fractions? What about this first one? It doesn't even look like a fraction, so what would the denominator have to be? 1. Okay, so what's the least common denominator then of 1x and x squared? Not x, because x squared won't divide into x. It's not 1 either. It's x squared. Why is it x squared? Good, because x squared is the smallest thing that they would all divide into, right? So if the LCD equals x squared, well, look what happens then. X squared divided by 1, x squared, it works. X squared divided by x is x. It works. X squared divided by x squared is 1. It works. Each time they divide in evenly, right? No remainder. Okay? So there's our least common denominator. All we've got to do then is just multiply both sides through by that, right? So we've got our 1 plus 5 over x equals negative 6 over x squared. We'll just distribute the x squared through both sides, and what happens? Well, what's x squared times 1? That's pretty easy. Just x squared. What's x squared over x? So then I'm just going to multiply the x by the top, right? Okay, so we end up with 5x, good. And then over here, x squared over x squared. 1. Yeah, it just cancels, doesn't it? Right? So over here we just get minus 6, right? So then if we go up and finish this up, it's a quadratic equation, but to solve that quadratic equation, what do I have to do? What's the next step? I gotta set it equal to 0, right? You have to set it, remember, and this goes all the way back. We need to do a little review on this, which we'll do tomorrow. Remember that if you can't point to a single x, you cannot isolate it, right? Then you have to put the equation in standard form and factor it and set the factors equal to 0. If you can't factor it and it's quadratic, what do you use?
The quadratic formula.
Yeah, right? And it gives you the answers, right? But factoring, if it's easy, is a lot easier. If it's easy. If it's hard to do, then maybe just jump right to the quadratic formula. So we'll add 6 to both sides. Oops. Okay, does that factor?
Yeah.
What are the factors? Good. X plus 3, x plus 2. Good. Okay, everybody buy that? Okay, what are the zeros then? Okay, maybe. That looks good, but we got to go back up and say, all right, that's fine, but what is our domain? Make sure that none of those have to be excluded. What value of x would make fractions equal to 0 on the bottom there? 0, right? That makes sense. That's the only one though, right? Here I've got an x by itself, so when x equals 0, I'd have a 0 on the bottom. Here I've got an x squared, same thing, right? Here I don't have any x's on the bottom, so it doesn't matter, right? So x cannot equal 0. 0 is not in, our answers aren't 0, so they're fine. Okay, one more.
So you, in Moodle, when it says that, you put in x equals negative 3, x equals 2.
Okay, so in Moodle, yes, yep. You just put the numbers. You have to put x equals.
Okay.
Right, because here's what it's going to say in Moodle. It's going to say the solutions are what?
Right.
And it also wants to know excluded values, right? Okay, so what about this one then? I want to factor that first one, don't I? I want to factor everything, denominators, so I can see what all the factors in the denominators are, so I can build the least common denominator, right? So that first one then, what does that factor into on the bottom?
-6, -4.
Okay, good, because that's, oops. Good, because They're both negative, they multiply to a positive, add to a negative, 6 times 4 is 24 and adds to 10, right? So that checks out. So then if that's the case,
Isn't there all?
okay, so what's my least common denominator gonna be then? Or what's my least common denominator gonna be if these are the factors in the denominators? Meaning x minus 4, right? Because I mean, the LCD, the least common denominator, is going to be the product of the factors. Okay, good. So we know that the LCD, oops, that's back on, is going to equal. We have to include the factor x minus 4 because it shows up there
X
and
minus
there,
6.
and x minus 6 because it shows up there and there. Now, just ask ourselves the question: Does that least common denominator include all the factors from this fraction?
Yeah.
Yeah. Does it include all the factors from this fraction, from the denominator? All the factors from the denominator of that one? So we're good, right? Okay, there's my least common denominator. I'm going to multiply through both sides by that. Before we go any further, though, let's go ahead and identify what's the domain. Let's do these different.
64.
Right, so the domain, we know that x cannot equal 4 and x cannot equal 6, right? So in Moodle, what would we do? X values that must be excluded are 4 and 6, separated by a comma, right? Now what? How do we solve this thing? What's our trick?
Times the least common factor in both are
Okay, well, good. We're going to distribute through on both sides the LCD, right? Okay, so then what do we get if we do that? Let's look. So we end up with okay, so what now? If I distribute that through, let's look at this. If I distribute that through, x minus 6 times x minus 4 over x minus 6 times, they cancel, don't they?
Yeah.
Right, so this first one, they cancel completely, and I just get a negative 2. Does everybody see that? Okay, next one. X minus 6 times x minus 4 times 2 over x minus 6. What's going to cancel there?
6.
Yeah, those cancel, right? And so I'm just going to multiply through by x minus 4, right? So we get plus 2 times x minus 4. And then what about over here? Those factors cancel, right? Because that's just one big division bar. And then on the top, we get the product of x minus 5 times x minus 6, right? Okay, so Justin, what do we get then if I simplify this?
So you're -2 out front.
Okay.
You're gonna go 2x minus 8.
What about over here?
Equals x squared.
Okay.
Minus 6x.
Minus 6x, okay, so we're distributing, we're doing this, right?
Yeah.
Okay, now what?
-5x.
Okay, he's distributing the negative 5,
And then 30.
that's 30. Okay, good. So now we got to combine like terms, right? Elliot, let's combine like terms. Anything over here I can add up?
I have a 2 and
Okay, good, so I'm going to get 2x minus 10,
Yeah.
right? How about over here?
the 5, 6, and
Okay, so x squared, what's negative 6x,
5.
negative 5x? Negative 11. Yeah, not that. There you go. Plus 30, good. Okay, so let's see, Maisie, now what? We gotta solve this equation, so what's our strategy here? Meaning, yeah, you're right, but what?
Like add 10.
Okay, good, so we're gonna move everything to one side. Add like terms, move everything to one side, good. So we'll subtract 2x We'll add 10, good. And that's gonna give us 0 over here. Here we get x squared minus 13x plus 40. Well, we can deal with that. That's a quadratic equation in standard form. Brendan, what's one way to solve that? We can't. It factors. No, we can't factor it. We can just break it apart and use the zero product property. We could factor it and find the zeros of the factors. Okay. What's another way to solve that? Gage? What's another way to solve that equation? What if we don't feel like factoring? What can we do? What we can always do, which is apply the quadratic formula, right? We haven't done that in a while. I'm not going to do it, but if I were going to, right, here's the formula, right? We all know the quadratic formula. I'll play the song again if I have to. I'll do it. So what are the values of A, B, and C that we plug in?
X, well, 1.
A is 1, B is negative 13, C is 40. There you go. Okay, but this one factors, doesn't it?
8 and 7 and negative 6.
Minus.
Wait.
8 and
Wait, just kidding, 8 and 5.
You're right.
Sorry.
Okay, so now let's see. Who did I want to pick on this one? I had somebody in particular.
Sir Williams.
Sir Williams. All right. So what are the zeros? Sir.
8 and 5. Nice.
Good.
Great job.
Okay, are those both legal?
Yes.
No, illegal.
They are. Okay. How come they are?
Because they're not near the bottom.
Okay, but that could happen to you.
The 6.
The 6, no, 4 and 6. I think we're good, right?
Still messed up in my.
Okay, but now I want you to know what would happen, because this easily it's variable. It could happen that way. What if we had gotten 8 and 6?
And 6 is gone.
We can't keep the 6. We can only keep the 8, right?
Right.
Okay.
6 is fake news.
Okay, are we done?
Fake news, exactly.
This is good
We're done. You may work.
Nice. What are we working on?
With what?
Well.